In this lesson, we will be talking about interpreting graphs. So once we have collected data through either a questionnaire or through an experiment, we often put it on a graph to help us understand the data a little better. So in our example, a hard-headed helmet company wanted to find out how many of its bicycle helmets had been sold in the last 6 months. So they surveyed 10 bike stores in Manitoba, and these are the results that they got. So in April, there was 12, May 21, June 56, July 63, August 37, and September 18. When we put this on a graph, we're going to put the month across the bottom and the number of helmets sold, as well as having a title. So the bicycle helmets sold in the last 6 months is our title. And you can see each of the points plotted. So in April, there were 12, so this would represent about 12. In May, there were 21, so I'm a little bit above the 20 line. And so each one of these have been plotted on the graph. There are only whole numbers of helmets that can be sold. So for example, a store cannot sell 12 3/8 of a helmet. So the graph is a series of points that are not joined. I can't connect these dots because when I connect them, it implies that I can have, and they use 3/8, but I like to think of it as half. Can I have half of a helmet, or can I buy half a helmet? Well, no, I can't. So I'm not going to connect these dots. These data are called discrete. So that's the fancy math term that we use. There are gaps between the values. Usually discrete data represent things that can be counted. So if I'm counting things, that's usually discrete. There are some other examples of what might be discrete data, but for our purposes, things that can be counted would be discrete. From the table, we can see that the greatest number of helmets was sold in July. So when I look at the table, I know that 63 is the largest number, so the most helmets were sold in July. And this corresponds with the highest point on the graph. So here's my highest point on the graph. And so there is July. This table and graph for the next example show Leah's height as it changed as she got older. So her years from 2, and this is kind of a complicated table because we have age and height and then age and height as she jumps from 10 to 11 years old. And we would guess that it goes up. So as we go, at 2 years old, she was 83 centimeters tall. And we've just plotted each one of these points as best as we can on this graph. Now, when I look at this graph, you'll notice that I did connect the points, because when we're talking about your height, you don't just wake up one morning and have all of a sudden added 2 or 3 centimeters of growth. It's something that is slow and steady, and there's definitely times when you are a height in between 83 and 95, or 95 and 101 centimeters tall. So the consecutive graphs are joined by line segments. And those line segments have meaning. So you can have each of those different numbers in between the points as possible answers. From the graph, we can see from 2 to age 16, the line segments go up from as we move towards the right. This shows that Leah's height increases, which makes sense. As you get older, you tend to grow. From 16 on, the line segments are horizontal. This shows that Leah's height has stopped increasing and she has stopped growing taller. This type of graph is called a line graph. It shows continuous data because I could take that data and I could record her height every single day. Continuous data can include any value between data points. Time, money, temperature, and measurements such as length or mass tend to be continuous. There are some practice questions here in regards to some of these graphs. Please try them out. If you have any questions, please let me know and I will help you out.